When you press the button on your microwave and hear that low hum, it feels like magic. Cold food goes in, hot food comes out, often in less than a minute. But there's no magic inside, just clever engineering and a bit of invisible physics. The core of every microwave oven is a device called a magnetron. It's a metal tube that takes electricity from your outlet and converts it into high-frequency radio waves, the microwaves that give the oven its name. These waves are a type of electromagnetic radiation, similar to radio waves or light, but tuned to a frequency of about 2.45 gigahertz. That frequency happens to be perfect for exciting water molecules. When you place food in the oven and start it, the magnetron generates these waves, which bounce around the oven's metal walls like echoes in a cave. The waves eventually pass through your food, where water, fats, and sugars absorb the energy. Water is the main player here. Its molecules start vibrating billions of times per second. This vibration creates friction, and friction produces heat. The heat then spreads, warming your meal from the inside out. That's why microwaves work so quickly. Traditional ovens heat air first, then the surface of the food, and only slowly does the heat seep into the center. Microwaves skip those steps, targeting the molecules directly. But there's a catch. Microwaves don't heat perfectly evenly. If you've ever pulled out a dish that's scorching hot in one spot, but still cold in another, you've seen the problem. The waves can create hot spots and cold spots, depending on how they bounce and overlap inside the oven. That's why most microwaves have a turntable to rotate the food, or a small fan-like stirrer inside to spread the energy more evenly. Even the door has science behind it. You've probably noticed the fine metal mesh in the glass. Those tiny holes are smaller than the wavelength of the microwaves, which means the waves can't pass through. They're trapped inside, keeping you safe while still letting you see your food. Microwaves are efficient too. Almost all the energy they use goes straight into heating the food, not the air around it. That's why they're faster and often more energy-saving than stovetops or ovens for small meals. Of course, they're not perfect for everything. Bread gets soggy instead of crispy, and some foods don't heat evenly. But for reheating leftovers, melting butter, or making popcorn, nothing beats the speed. The next time you hear that steady hum and see steam rising from your meal, remember, it isn't magic. It's carefully directed electromagnetic energy, bouncing inside a metal box, shaking water molecules until your food is hot and ready.